vastness of the cosmos that surrounds us. It's a realm so vast, so expansive, that it pushes the boundaries of our imagination. Try to picture an infinite universe, a cosmos without end, continually expanding into the fabric of nothingness. In our quest to comprehend this enormity, we turn to the Big Bang theory. According to this theory, our universe was born from a singularity, an infinitely small, hot and dense point, around 13.8 billion years ago. A colossal explosion, a bang, set the universe expanding, a process that continues even today. To further validate this, we look at the cosmic microwave background radiation. This radiation is the afterglow of the Big Bang, a snapshot of the universe when it was just 400,000 years old. It's our oldest snapshot of the universe, a relic from an era long past. As we explore further, the cosmos only seems to become more mystifying and enchanting. But what exactly fills this vast universe? Let's delve into the celestial bodies that make up our universe. The cosmos is a grand tapestry woven with a variety of celestial bodies. Stars, for instance, are not just twinkling lights in the night sky. They are colossal furnaces where nuclear fusion occurs, converting hydrogen into helium and releasing an enormous amount of energy. Over billions of years, stars undergo a life cycle, born from clouds of dust and gas, and eventually meeting their end in spectacular supernovae or tranquil white dwarfs. Next we have galaxies, vast islands of stars, gas, dust and dark matter. They are the grand stage upon which stars live out their lives. Galaxies come in a variety of shapes and sizes, from spiral to elliptical, each one a testament to the incredible diversity of the universe. Now let's move on to the enigmatic black holes, celestial bodies that have long piqued our curiosity. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. They form from the remnants of massive stars after a supernova explosion. Black holes are not just fascinating, they're also key to understanding fundamental concepts in physics. And there you have it. This is but a brief overview of the celestial bodies that populate our universe. Each celestial body, with its unique properties and behaviors, adds to the complexity and beauty of our universe. Now imagine if time could stretch and warp like a piece of elastic. In the realm of astrophysics, it's a reality. Welcome to the phenomenon of time dilation, a concept deeply rooted in Einstein's theory of relativity. It's a bit of a head-scratcher, but let's break it down. Imagine a cosmic speedometer. The faster you travel, the slower time ticks for you. This is special relativity at work. Now let's add gravity to the mix. Just as speed influences time, gravity does too. The stronger the gravitational pull, the slower time passes. This is general relativity. Put simply, time is not absolute. It stretches and contracts based on speed and gravity. It's as if the universe has its own rhythm, a cosmic dance of time and space. And there you have it. Time dilation, a mind-bending concept, truly showcases the surreal nature of our universe. What if we told you that the universe is constantly humming with a cosmic symphony? Imagine a celestial orchestra, playing a tune that's far beyond our hearing range. This is the concept of gravitational waves. Gravitational waves are ripples in the fabric of space-time, caused by some of the most violent and energetic processes in the universe. Picture two neutron stars spiraling towards each other, their dance of death creating waves that spread out across the cosmos. Or a black hole swallowing up everything in its path, sending out tremors that echo through the universe. These are the dramatic events that generate gravitational waves. But why are these waves so significant? Well, they provide us with a unique way to study our universe. Just as light waves let us see the universe, gravitational waves let us hear it. They carry information about their cataclysmic origins, allowing us to study events that happened billions of years ago, events that are otherwise invisible to our telescopes. Gravitational waves open up a new window to the universe, a new way to explore the cosmos. They are like music notes, each wave carrying a different tune, each tune telling a different story about the universe. Gravitational waves, the cosmic symphony, allow us to listen to the universe in a whole new way. And just like a symphony, this cosmic music helps us better understand the grandeur, the complexity, and the beauty of the universe we inhabit.